All right, we are now on section lesson 6.3, and the title, the emphasis of today is going to be on geometric sequences and series. And so right off the bat, let me give you an example of each so that you can understand what it is we mean when we talk about a geometric sequence. I've given you an example of a geometric sequence. So maybe you can put it in words. Somebody can describe for me in words, in general, what is a geometric sequence? Okay, I like that. It's a pattern. It's a list of numbers that follow a particular pattern, and Joe just gave us what that pattern is. To get from one term in the list to the next, we're multiplying by the same number each time. And in this case, what is that same number? 3. And that number that we are multiplying by the same in each time, the 3, is called the common ratio. So when you see the letter R referred to in some slides coming up, that's what it's referring to. What is that common ratio? What is that number that is used to multiply by each time to get to the next term? All right, so that is a geometric sequence. Well, let's just take this same sequence and turn it into a series. Well, this is not very tough because here's a series. Same numbers. I'm just going to show that they're going to be added up. And if you got your calculator, maybe somebody can give me that sum. So a series is a sum for a particular sequence. We show that the terms are being added together. And I'll try from memory here. Is it 728? 728 would be the sum of this particular series. So do you see the difference between a sequence, which is a list that follows a pattern, multiplying by the same number, versus a series, which is a way to represent the sum of the sequence? Okay? So with that said, let's get into some specifics regarding your homework. So first of all, I want to make sure you understand some symbols, some notations. This first block of problems, 18 through 21, are going to ask you to find what they call A sub n. And what they mean by that is there's going to be a particular sequence, or at least we're going to have some information about a sequence, and they want us to find a particular term in the sequence. Like A sub n means find the nth term. It's open-ended. When I get specific, when I say A sub 3, that means, okay, out of this list of numbers, what is the third one? So I just want to make sure you understand when you see this notation what they're talking about. All right, so here is the formula that you're going to need to find any. So I just left it open. If you want to find any, what we'll call the nth term of a sequence, a list, here's how you will find it. A sub n, any nth term in the sequence, can be found by taking the first term, we'll call that A sub 1, times R, and what does R represent? The common ratio, that number that we're multiplying by each time to get from one term to the next. And R is going to be raised to the n minus 1 power. So you're going to use this formula. It's really not a hard formula to use. I'll just go ahead and give you a heads up about the next test. You're going to be accumulating several formulas, and it's going to be your job to not only know them, but to know when to use them for particular problems. That's usually the struggle that people have on tests like this. One formula at a time, no problem. But when I throw several different types of problems on the test, and you got to go into your brain, you got to pull out the right formula and know how to use it to answer that particular problem. So that's where practice, doing your homework with purpose, not just trying to get it done, is really going to come in handy to get ready for this next test. All right, so with that said, let's find the nth term for this problem letter A. All right, so I can find the nth term by taking the first term, which is given, 18, and multiplying that. Don't really need to show multiplying. I'll just show parentheses. I'll put R, 1/3, to the n minus 1. Okay, and now I'm going to replace n because I just wanted you to see how the formula works to find any nth term. They're going to get specific, and they say, okay, let's find the 11th term. N is 11. So notice what happens. N will become 11 in both of these places. So to find the 11th term, we just grab our calculator, and we plug 18, parentheses, 1/3, and raise 1/3 to the 10th power. So when you get that, raise your hand, let me know. Anybody got a number? Parker?
I got 0.000.
Okay, who else got that? All right, good job. Any questions? No questions? All right, let's move on to letter B. More practice with that formula. So here I'm just going to jump in. I know I'm finding the 13th term, so A sub 13 is going to equal the first term, which is 3/7, times R, which is 4, raised to the n minus 1 power. 13 minus 1 is 12. And let's see what you get. So if you're using your calculator, I would use parentheses, definitely. Parentheses 3/7. And then the calculator will do the order of operations for you. It should do the power first, 4 to the 12th, and then that result times 3/7. Okay, who wants to give us that number? Pretty big number. Dominic, what is it?
I got
7,490,000. 190,000. Okay, who agrees with him? Okay, so what'd you get, Parker?
I got 7,190,235.49.
You just, yeah, you can't just make up your own numbers, Dominic. You got to give me what. Yeah, I know, but yeah. So write down whatever your calculator says. So who got it? Great. You notice how R is a number, not a fraction. We should get bigger and bigger, obviously. When R was a fraction, then we should get smaller and smaller each time. Okay, try letter C real fast. Find the 9th term. A sub 9 is equal to the first term times R raised to the n minus 1 power. So we're going to raise it to the 8th power. Okay, who's got it? Somebody different? Jared, what'd you get? 9, 1. Okay, raise your hand if you got that. Great. Okay, so really just a little bit of practice getting used to this formula to find any particular term in the list of a geometric sequence. And that's what these first problems are all about. Okay, now more practice, but this is going to be an open-ended. How would you write a formula or an equation to find any term? They're not going to get specific and say, find this particular one in the list. How would you find any term in the list? Well, we're still going to use this formula in general. But if we're looking at letter A, there's some things that I see that I know. I know what the first term is going to be. So I'm going to leave this open. I'm going to find any nth term. So A sub n is going to be the first term, which is 2. I can see that. What I don't see right off the bat is R. I mean, they don't just come right out and tell me what R is, but you could probably tell what it is. And in cases where it's more complicated than this, where maybe you can't tell just by looking, you can always couple these together and then do a division problem of the second term divided by the previous. And if you can do that same thing all the way down and come up with the same result, you know that that number has to be R. So here I am, as I couple these together, just slide down by one term and put these in a pair, and always divide the second in the pair by the one before it. Notice how every time I do that, I'm getting 2, and that tells me what R is. Now you could tell that just by looking, but sometimes you can't. Sometimes it's a little more challenging to tell what R is, but this will always give it to you. All right, so to come up with any nth term, I'm going to say the first term times R, which now we know is 2, raised to the n minus 1, and that's my answer. Now letter B, a little trickier, because they give us the second term. Well, the second term doesn't help me in this formula. I got to have the first term. Well, can you tell if negative 96 is the second term and the common ratio is negative 8? Can you tell what the first term would be? Something multiplied by negative 8 to give me negative 96. Or, think of it this way. What's the inverse of multiplication? Division. What if we divided negative 96 by negative 8? 12. Okay, so now we know the first term is 12. So now we can write the formula. So give that to me, Gracie. And we're going to put A sub n equals that. Some nth term can be found in this sequence by using this formula. And if I want to find the 15th term, I just let both of these n's become 15. And I use my calculator. Okay, what about letter C? They gave you the fourth term, they gave you the common ratio, but we need the first term. How do you think we're going to find it? Okay, if we divide by 3, 54 divided by 3 is... Calculator? 18. Okay, that's the third term. Divide by 3 again, and 6. That's the second term. Divide by 3 again, and 2. Okay, we found the first term. Now we can use the formula. Do you follow me with that? Okay. So let's see. Emily, give me the formula here to find any nth term. A sub n equals 2 times 3 to the, let me erase this, n minus 1 power. Good. Questions? So just want to make sure you understand, because some of your problems, they're going to make you work a little bit to find out that first term. Just want to make sure you follow how we got there. Okay, part 3. Let's talk about geometric mean. And this comes in handy in problems like this, where we're given a part of a geometric sequence and we have some missing terms, and it's our job to figure out what those missing terms are. Well, if it truly is a geometric sequence, we use this concept of geometric mean to find those missing terms. It's really pretty simple. If I want to find the missing term in between these two, given that this is a truly geometric sequence, here's geometric mean. I take these two terms on either side of the missing term. Okay, 3 from the left, 48 from the right. I use my calculator, and geometric mean is the square root of that product. So if I want to get geometric mean, in this case, in my calculator, I do the square root of 3 times 48. And that should be 12. So the missing term in this geometric sequence would be 12. And I found that out using geometric mean. Well, your book isn't quite so nice. They didn't say find this one missing term. They said find 3 missing terms. Well, that's not too bad. Just think about, first of all, targeting this one in the very middle first. So how do you think we would get the one in the very middle? Yeah, we take these ones on the outside and we do geometric mean. So Wynn, help me out. How would I find the geometric mean to come up with this very middle term? Okay, square root of 0.25 times 64. And let's see, who's got that? Gracie, you got that? 4? Okay, well that helps me then to find the geometric mean, or the missing term, for this. How do you think I'll do it? Yeah, just use these. So it makes sense to start at the middle, and then you can find these other two pretty easily. So I'll give you a second to come up with those answers. Reese, what is the left blank? And Ty, you got the right one? Anise, what do you got? Okay. So it looks like R is what? 4. R is 4. Okay, good. Questions? Any questions so far? Another formula. Okay, we'll just keep adding to the list. Here's the formula for geometric mean. It's pretty easy, but just need to remember it. All right, I'm going to give you a few seconds to come up with these 3 missing terms. Okay, what's the very middle one, Ty? Good. The one to the left of that, Parker? And the one to the right of that, Jared? Okay, would it be wrong if, let's say, well, first of all, what's R? 5? Okay. Would it be wrong if this were -1, +5, -25? I mean, if somebody wrote that in, would that be wrong? I mean, could that be true? We don't really know. They didn't tell us that R is 5. What if R was -5? Could that also give you, I mean, you get different numbers. If R is -5, that makes this one negative. This one would be positive, negative. You see that? So technically, you could have also said this, and you wouldn't have been wrong. But for us, you can just stay with the positives. Okay, I just wanted to clear that up. Because they didn't tell us. They didn't say, well, R is +5. What if R is -5? Well, then that would make these negatives. And negative times negative is positive. Positive times negative is negative. So they just alternate back and forth. But we'll make it simple, and we'll just say, I thought, well, maybe that would come up when you're answering these. What if these were negatives and they alternate? But you can just leave your answer positive. Okay, well, same thing here, but a little different twist on the problem. Here are two numbers on either side of two missing numbers. And it's our job to find the two missing terms. They call them geometric means. Well, here's how we're going to do this in this particular case. How many total terms are in this sequence? If we have this one, and it doesn't indicate that it keeps on going, it's implied that this is the first one, this is the last one, and how many are in the middle? How many are in between? Well, there's two missing. So how many terms do we have altogether? 4, right? This one, missing, and this one. Okay? So that's going to help us when we turn to our formula that we've been using. If I wanted to use a sub 4, meaning the last term, what's the last term? 1,372. What does this indicate? First term. What's the first term? 4. Okay. What is R? I don't know. But I can plug in everything else but R, and we can solve. So what do you think the exponent for R is going to be? How many terms did we say there are in this? 4. So what's the exponent for R going to be? -1. N means 4. So R to the third. Okay, let's solve for R. If we can figure out R, then we can unlock this problem. We'll know what to multiply by to get to the next term. So give me a first step on finding R here. Okay, go ahead and do that. 1372 divided by 4. And what is that, Win? All right, now what? What are we going to do, Emily? Cube root. Okay, so I just leave 343 in your calculator. And this is a way to do the cube root. Just make sure you use parentheses. And Gracie, what do you get for the cube root of 343, which is R? 7. Okay. We know what R is. R stands for the common ratio. That's the number we multiply by each time. So what is that? After 4, what is that next term that's missing? 4 times 7. 28. Okay, Parker, what's the next term that's missing? You can use your calculator if you need to. Well, we know what R means what we're having to multiply by each time. So if you know that 28 is this term, how would you get to the next term? There you go. Yep. Okay, and we've gotten our answer. We found the two geometric means, but it's going to require on these two problems, 39 and 40, when you get to these two problems, look back in your notes and you'll do exactly what we've done here. You're going to use this formula to try to figure out what R is so you can tell what these missing terms are. Any questions there? Okay, good. All right, we're almost done. Now we're into series. Remember the difference between a sequence and a series? A sequence is a list, follows a pattern. A series is the sum of the list. So now we're going to work on another formula. Here's how we find the sum of and I say finite because maybe a little later on we'll actually be able to come up with the sum of an infinite geometric series. That's pretty cool. All right, so here's the formula to find the sum. Now notice I'm not using A any longer, A sub n. I'm using S sub n. S stands for sum. Here it is. First term multiplied by 1 minus r to the n power divided by 1 minus r. So just add it to your formula list. Practice it well. Not hard to use if you have a calculator, but you just need to remember it and when to use it. This is only for finding the sum of a geometric series. Okay, so let's take this formula and apply it for problem letter A. All right, how many terms am I adding up? Well, apparently I'm adding up 10. N is 10, so let's find S sub 10. What does A sub 1 stand for? Okay, it stands for first term, which means 2 in this case. 1 minus R to the n power. Well, if I'm looking to add 10 terms, that means this is going to be exponent 10. Divided by 1 minus R. So let me give you a heads up about one particular common mistake that people make right here. Here I am keying into my calculator. 2 parentheses 1 minus 3 raised to the 10th divided by 1 minus 3. What's the problem there? The calculator is very, very obedient. And if I key it in just like this, here's what it's going to do. It's going to do all this numerator stuff. It's going to divide that result by 1, and then it's going to take that result and subtract 3 from it. Is that what I want it to do? No. So how can I fix that? Very important. Yes. Anytime you put an operation in the denominator, unless you just want to key in -2, that would be okay. But a lot of people don't trust themselves to do the math. So if you're going to put an operation like this in your calculator, you need to put parentheses around it. So give me that sum. Jared, do you have that? 59,048. Okay. Show of hands if you got it. Very good. Very good. And one more. I wanted to show you this because this is another way of expressing the sum of a series using what is known as either sigma notation or sometimes it's called summation notation. Who's got Dr. Zockel and you're learning Greek? Yeah. So this looks familiar to you? This is uppercase sigma. There's also a lowercase sigma. Well, in math, when you see sigma, it always means the same thing. It means the sum of. That letter is used a lot. If you've used the program Microsoft Excel, there's actually a button that looks just like this, and you can add a column of numbers just by pushing that button. So when you see sigma, it means to add. All right, so we're going to use that same formula. It's just that where we get the parts for the formula, a little different when we're getting them from sigma notation. So let me write the formula up, and then I'll show you how to plug in. I think I'm just going to start with this and just replace, if that's okay. You can rewrite it. All right, so first of all, how many terms? Well, here's how you can get the number of terms from sigma. Take this top number, 6, subtract the bottom number, and then you're just always doing plus 1. So how many terms are in this? 6 minus 1 is 5, plus 1 is 6. Now I know what you're thinking. Wouldn't it be easier just to look at that? Is that what anybody thinking that? Be honest. I mean, wouldn't it be easier, save a little bit of time? And you would be right, but later on, when we get a little bit deeper into sigma notation, this might be 3. Now there's no longer 6 terms in this. Because when I come up with the sum for this whole series, I'm not starting with term number 1. I'm starting with term number 3. Now how many terms are there? The third one, the fourth one, the fifth one, and the sixth one. How many? 4. Okay? So you're going to have to trust me. They made it pretty easy on you for this assignment. They made this bottom number 1. So yeah, you can just take a look up there and that's the number of terms, but that's not always going to be the case. So you'll do yourself a favor if you'll train yourself to do top minus bottom plus 1. It's going to come in handy later. Okay, so I'm doing the sum of 6 terms. Okay, so we've established how to find the number of terms that are being represented by this sigma notation. So let me just one more time warn you for future reference. please don't think that you can just look at this top number of sigma to identify the number of terms. When this bottom number changes, let's say you were given this where k equals 4. Well, now, instead of saying, well, there's 6 terms in this list, well, actually there's not. I would say 6 minus 4, which is 2, plus 1. There's actually 3 terms being added up according to the way it's written now. So train yourself. Once again, you'll be better off for it if you train yourself to think top minus bottom plus 1. All right, so back to the rest of our formula. Put this back to the way your problem says. Okay, so we know what n is going to be. Here's how you can come up with the first term. If you're looking at sigma notation, just let k, you notice how it says k equals 1 below sigma, and then you have this exponent that has k in it. Then if you want to get the first term, just replace this k with 1. And then do the math. It'll be 3 times negative 2 to the 0 power. And negative 2 to the 0 power is 1. So in essence, you're saying 3 times 1. So let me just show you what that looks like. Anytime you want to find the first term, I'll just repeat that. You take the bottom number of sigma, which is 1, and you replace the variable that it says it equals, which in this case is k. And doing the math here will give us the first term. Another way of looking at this, non-mathematically, is the first term will always be whatever this number is that in the past we've identified it as the a number. So, and you can tell how that works out. Negative 2 to the 0 is 1. 3 times 1 is 3. Okay, so a sub 1 stands for the first term, and for this, that's going to be 3. 1 minus r. Okay, well, remember we just looked at a formula that had r to the n minus 1. R was that number sitting below the exponent. So let me go back to a few slides ago. Notice how we were looking at this formula. It said r to the n minus 1. So if you're looking at summation or sigma notation and you want to know what is that common ratio, or r, just take a look at the number directly underneath the exponent. That's the easy way to get this. And so in this case, r is negative 2. Remember, we've already identified n. N stands for the number of terms. So since I let n become 6 here, I'm going to also let it become 6 here. And then the denominator is going to become 1 minus negative 2. Okay, so here's a couple of heads up items, common mistakes that people make. Here's probably the most commonly made mistake in this problem. Remember, the order of operations says we do exponents before we do adding or subtracting. Well, I see a lot of people go ahead and change this into plus, and then they'll say 1, or they'll go ahead and do the exponent from this point and then add 1. Well, that's really out of order because we do not do subtraction. You've already done the subtraction of a negative number, and then you've changed both of these to plus. So you've violated the order of operations. So here's what you should do in this case. So be very careful in this particular situation. You can go ahead and plug all this into your calculator, but definitely you don't want to plug this in as plus 2. If you're doing it one step at a time, you want to do negative 2 to the 6th power first, and then you're going to do 1 minus whatever that number is. Another common mistake that people make, we've talked about this before, when you divide using your calculator, you want to make sure if you don't just call this 3, then you want to put this in parentheses and say 1 minus negative 2. Okay, so what I would do is just say divided by 3. Then you don't need parentheses. But if you don't trust yourself to do the mental math, make sure you put parentheses around operations like this. Okay, so let's grab our calculator, and we'll see if you come up with the correct answer. And we'll pause the video and take a few seconds and see if we can get this. Okay, so hopefully you've used your calculator and you've plugged in correctly, and you should have gotten a final answer here. The sum of these 6 terms should be negative 63. And if you weren't able to get that, then just go back and keep working with this formula. That's really good practice. And then once you've identified the way you got negative 63, take note of that, and that'll help you correct any errors for the future. So that wraps up the lesson and the assignment also on RenWeb, but this is what we're going to be working on for next time. And if you have any questions, you're welcome to email me or come to academic support.